So today I want to work on not one, not two, but three controllers. And at the first glance you might think these are three PlayStation 2 controllers, but actually one of them is a PlayStation 1 controller, as you can see right here. So it's this one. You can also see the 7 screws on the back right here. And today I want to try and fix them all. And I think we might be looking at some different type of fixes. In fact, this controller is not even faulty. I have tested all of these controllers and they do all have different faults, which I think should be interesting and why I want to feature them all in this video. So first of all, with the PlayStation 1 controller, the controller is not actually faulty, so everything is fully functional from the analog sticks to the shoulder buttons and the front buttons. The issue is that the responsiveness of the buttons sometimes is not so good or is not responding at all, which mainly happens when you try to push buttons in a quick succession. So if I go like this, then it would register properly. But if I go like this very quickly, then it does not register either of them or maybe even none at all. Frequently, that is caused by the rubber pad which sits under these D-pad, for example, and the rest of these buttons, especially on the PlayStation 1 controller, which, well, is over 30 years old at this point. Over the course of a few decades, these controllers have degraded, so the carbon which is supposed to connect to the flex PCB is just not as responsive anymore. And there is a simple solution for that actually, which I do frequently on PlayStation 1 controllers. If you have some kind of post-it or any type of paper, then you can basically push the rubber pad over the paper to basically get a new layer of carbon, which should help in getting the controller to be more responsive. And besides that, what I also tend to use is a pencil and basically go over the rubber pad, which basically gives it a bit of a fresh layer of carbon, which also helps to make a better connection. So that is the plan for this controller. Then we have two PlayStation 2 controllers, which are both the Model H controller. And if you are familiar with those, then you know that there is a very specific issue with the flex PCB on these controllers, which goes faulty frequently. It's a very high failure rate, and this controller is suffering from that. So I already made a video about this in the past, but I thought, why not make another one and just quickly show the fix for that, how you can replace the flex PCB on a PlayStation 2 controller. And last but not least, we have another Model H, which basically does not respond to anything at all. So the controller does actually get power, so the analog light does come on, but I do not get anything. Not from any buttons, not from the analog sticks, and not from the start select buttons. When normally if the flex PCB has failed, you will get response from these three buttons right here, but the rest of them have failed. But since here I get nothing from anything, but power does come into the controller, I thought it might be interesting to take a look at this and see what is faulty with it. So now that we have introduced all the faults with the controllers, I think we will start with the PlayStation 1 controller and I will show you how you can fix up those rubber pads. Alright, so I have torn down the entire controller and now we are left with the rubber pads which I was talking about. And basically the first thing you want to do is to give these a bit of a clean, since there can always be a bit of grime and dust in there, and of course that does not help with the button presses either. That can also cause bad responses. So before we are going to work with the paper, just want to take a Q-tip, put some isopropyl alcohol on there. You can be pretty generous with it and just give everything a bit of a clean. Alright, so we have given them a bit of a clean. If I hold it into the light a bit, you can see pretty clearly that the pads look a little bit dull under the light, which is definitely a sign that the conductivity has degraded over the years. You can see it on these other pads as well. So these have degraded definitely a little less. It might not even be necessary to do the whole paper trick with these ones. Maybe this one does. This membrane frequently looks pretty okay actually. It's definitely mostly these pads which will look the worst. But now that we've cleaned them, you can grab one of these pads and have a piece of paper. This is some kind of post-it. And we want to just drag it around here like this. You can see a bit of a mark on there. It's very faint. And you basically want to do that a couple of times. I do basically 3 times for each side. You don't want to press super hard. You of course want to have some conductive material left. But just some moderate pressure will do fine. Now if you look at it, I don't see too much of a difference. It does seem that it looks a little bit more clear. There's more lines visible. This will not be perfect. And I think definitely since these do degrade quite a bit, that maybe replacing them might be the best long-term solution. But of course this little thing costs $0 basically. So it's very easy to do. And it will definitely help to prolong the life of the controller. And now we have a bit of a nice clean surface to work with. So I will take my pencil. And what we basically want to do is to go over each of these ones and just give it a bit of a scratch like this. Basically want to cover the whole pad. Again, you do not need to press hard. Just a little layer on there. I don't even think it's very visible. Alright, so those are all the buttons done. I did not do the pencil thing on this one since this membrane is in good enough condition that I don't think it's necessary. But I will put the controller back together and then we can see if it has a better response time than it had before. So something I quickly want to mention is that for the PlayStation 1 controller specifically, with these screws, these are not Phillips screws, but actually they are Japanese international standard screws. And thus I will be using a screwdriver which is also Japanese international standard. These ones are from iFixit, I think, because especially on the PlayStation 1 controller, it's very difficult to get away with using a Phillips screwdriver since it's very easy to strip these screws. I feel like on the PlayStation 2 controllers, it's definitely easier to just use a Phillips screwdriver. They are more resistant to those screwdrivers since so it will not ruin the screws instantly. So apparently I have lost a screw somehow from the PlayStation 1 controller. I will try and find that hopefully quickly, but for now it's not needed. It's just one of the 7 screws, so this thing should be perfectly fine. Since this is a Model A PlayStation 1 controller, we can just put this in lastly. It's not possible for every PlayStation 1 controller revision, but for this one we can actually go ahead and do that. So that is the controller fully back together. And since I have my PlayStation 2 set up on my PC with a RCA to HDMI converter, I should actually be able to turn on the PlayStation and then we should be able to test it. So I will be going into a voiceover over this gameplay since I did not actually have my audio set up to the correct scene, so that unfortunately got lost. But basically what I'm doing here is just testing all the buttons and you can see that responses are basically perfect. It's super responsive and I think even more responsive than the controller came from the factory. So that is all due to the little layer which we put down with the pencil. And yeah, it was basically really successful. And it's a nice and usable controller now, which is great news. Also want to mention that I did end up replacing the right thumbstick since the original one was chewed up a little bit on the side. So it's unfortunately a little bit of a different color, but yeah, it's also really difficult to get the exact correct replacement part for these PlayStation 1 controllers. I did actually look through my pile of stuff, but this was the closest I could find. So this controller will actually go back into my collection, since I like to collect these controllers frequently. And I did not have a black PlayStation 1 controller yet, so it's really nice. So I think we should move on to the next PlayStation controller. So here is controller number 2, and this is the controller which has the infamous Flex PCB fault. So let's open up the controller and we can take a closer look at it. And here is the inside of the PlayStation 2 controller, and the revision we have here is the most common one. which means that this black connector right here is basically crimped together with the green flex PCB, which we can see a little bit of right here. And that means not only do we need to replace the flex PCB, we also will need to take off this connector. And there's a few ways you can go at it. I mean, I've always used a hot air station to make my life a little bit easier, but it's also possible to use a soldering iron. I would use a big tip for that, one that can transfer a lot of heat. And you can basically go left to right with the soldering iron until that pops off. The first thing I will do right now is we will basically cut the flex PCB. Cut. Not the most pretty, but it did the job. And now we can basically take out the motherboard and we can separate this from the plastic piece, since we definitely do not want this in the way. And we can basically get rid of this one. And what we will need is a replacement flex PCB. This is the SA1Q42A. You also have the 43A, which will be a lot greener than this one. And the big difference is that right here on the R2 and L2 sides is that this will be a little bit thicker and it will not directly fit into the plastic piece right here. Instead, you will need to cut a little bit of the plastic on each side. Be aware that you do not cut traces on there. Then you can basically just install it. In this case, we have a 42A, so we can instantly install this. If you want to buy the 42A, make sure you get the legit version of that, since there are some fakes out there from the 42A, which will have the down button and right button reversed. So here we can see that this is the first trace, L2, then L1 is the second trace, then up is the third one, then down is the fourth one. No, excuse me. Left is the fourth one, then down is the fifth one, and this is the sixth one, the right one. On fake ones, these two will be swapped. So then this one is the fifth trace and this is the sixth trace. And those will not work with your PlayStation 2 controller. I've made the same mistake and I have literally 50 of these non-working flex PCBs around. So pay attention to the pictures if you want to order this version of the flex PCB. Since it's very easy to get mistaken on that. And this should all just pop into place easily. Just like that. So this is already prepped. Save some time later. Then you will need a connector piece. In this case, I always buy the 18 pin one. So the flex PCBs I have are also 18 pin and this is as well. On the original controller, it will be a 19 pin you are dealing with. And what we will do is we will skip the first pin when reinstalling the connector. Instead, we will go from this pin all the way to this one. This one will be a no connect. I've put the controller in a board holder. What I like to do now is just to put a bit of flux down here, which will help a bit with getting the connector off of here. And the temperature I will be using is, I think I will go with 300 Celsius and the airflow speed goes to 45%. There will be a little bit of smoke which can come off of here, especially from the plastic melting, that is possible. So I would recommend you run a fume extractor when you are doing this. And yeah, now it's just a matter of going left to right, make sure you move the air around and then the connector should just pop off anytime. I'm going to up the temperature a little bit. I'm going to 330 Celsius. See if that helps a little bit. Okay, it's finally going off. Just be a little patient. Don't just yank on the connector, or else you have a chance that you are going to take off traces of the motherboard. It did take a little bit longer than expected, and I've not really done a lot of these connectors with this new hot air station. I've mostly done them with a cheaper hot air station, so I'm not too familiar which configuration works the best for these connectors. I think I was a little bit too conservative with the temperatures I've chosen. So I ended up at 350 Celsius and 40% airflow, which ended up doing the trick. So this is basically just a dry Q-tip which can take off the flux pretty easily. So there's still a little bit on here, but we can deal with that later. So what I want to do now is get my soldering iron. And just a little bit of flux to help a bit. And I want to prep these pins right here. I'm not going to take off the old solder. It's not necessary. Then we basically just drag that across here. And we can just prep the pins like that. I give it a bit of fresh solder. That should do. Then we take our connector and like I said, we skip the first pin. So you basically want to align it as best as possible. It does not have to be perfectly straight. It happens regularly that even from the factory they are definitely pretty skewed. Like that can happen. But of course we want to get it as straight as possible. I think that is fine. Again, a little bit of flux on the first and last pin. Then we grab our soldering iron again. We want to anchor down the first and last pin of the connector. It might move around a little bit. You just want to anchor that down. You might accidentally bridge some connections. It's not a big deal. Just can go over that again and it should clear up. Then I will just basically flood some flux right here. Just be very generous to make my life a little easier. And then we can basically just drag the solder around the pins. And it might be necessary to do that maybe a couple of times. I think it looks pretty good. Then we want to quickly check all of the pins. See if they are all connected. This one is not connected, the second pin. So we might need to just touch it up a little bit. And for the rest of it, all the pins are clear, so they're all connected. They are not connected to each other. They all look nice and clean. So I'll try and show it close up. You basically see my work right here. So that is looking pretty decent and will definitely do the job. So now it's just a matter of cleaning up and then we can put the controller back together. So what I like to do is to already put these two parts together before we are going to install it into the shell. I think it's a little bit easier since you do not have a lot of space to work with once everything is into the controller. Make sure you also rewire this properly, the strain relief. And then this sits like this. Then I will get my pair of pliers and we should be able to grab this flex PCB part. You will not be able to get it perfectly straight. I tend to grab it like this. Then we can basically move it into here. Might sometimes want to go out a little bit, but you want it to look like that. That will make a perfectly fine connection. Then we can just install it into our front shell. Sometimes these analog sticks need a bit of a wiggle. Also, your LED should be straight into the hole where it goes into. Of course, make sure no wires are getting trapped under here. These ones are nice and free, so that should be perfectly fine. We can put the motherboard screw in here. Just make sure everything is nice and flush. Oh, and side note, if you see these little black plastic pieces right here, as you can see on the other side, these are really fragile and they will basically fall off eventually. Especially if I see that there are already plastic pieces missing like this, I will just break off the remaining ones that are there since that is definitely very weak. So if you take our pliers, you can already see this is basically already loose. So if I just do this, then it's already let's go. So if you do not want anything rattling about in your controller, just take them out preventively. Will save you opening of the controller another time. Then we can install the front buttons and then we take out the back shoulder buttons right here. Just like that, since we will also be installing these lastly. That's definitely a lot easier than trying to fiddle around with it once the shell's back together. I have in fact not cleaned out this controller. I will just test and see if it works, and then after off camera I will give the controller a nice clean. Then it should be very easy to pop these into place. Might need some wiggling around. If you put them into basically like this, a little bit screwed, you might actually break off one of these little legs. So you need to make sure that it is nice and straight. You cannot really push them in like this, but you can basically need to fold them a little bit. Just press on them on either side and then you should be able to wiggle them in like that. So that is that controller back together, and I think we should just test it like with the other controller. So here we are again on Tony Hawk 2. Basically the controller is working perfectly again, kinda as expected, so at least we know that the installation of the Flex PCB was successful and all of the buttons are responding very nicely. So the PlayStation 2 controller is basically just like new. So that means that we got another controller fixed. So let's now move on to the last controller. And here we have the last controller, which is completely dead. So I think we should just open it straight up. So interestingly enough, here you can see that we have the other revision, which is good news for me since that makes it easy to just swap out the Flex PCB as a preventive measurement. If of course we get this controller to respond at all, with which I'm talking about the analog sticks. So I think the first thing we can do is actually grab our multimeter and just test the continuity of this cable right here. Of course we do get power, but since nothing is working on this board, I think it's just a good start to begin with checking out the cable. I mean, if I look at it visually, there's nothing really wrong with it. It's actually a really clean cable. There's no tears in it or any cuts, no duct tape anywhere on it. So it looks really clean. Of course, it's always possible that internally there's something wrong with the cable. So I will set it up like this, and the meter again will be in continuity mode, which is of course the mode that beeps. So if you have a very low resistance, I think in this case it's lower than 50 ohms, you should get a beep, but in case of this cable, we should get close to 0 ohms for it to be a proper connection. I have no idea which cable, which pin goes to which point on this cable, so I will need to trial and error this one. Okay, there we go. So it's the middle pin right there, which is this, in this case, this is the positive, which does have continuity, and that does make sense since we do get the LED that lights up when the controller is connected. So I'm not too surprised that is working. So next up we have the ground point. And we also get the connection right there. Then the rest of them will all be some kind of data pins. Oh, I heard a small beep, so I think it must be one of these. There we go. Then we go to pin 4 on the motherboard. Also has continuity. Now we go to pin 5. Has also continuity. Now we go to pin 6. Also has continuity. Pin 7. Also has continuity. And the last pin, need to search where that is located. I will go over each of these pins slowly. And there is pin 8. So the cable seems to be functioning fine, if I have to believe the multimeter. If I look at the solder joints visually, they all look nicely connected to me. So there's no cold solder joints on here in this instance, which makes me a little bit concerned that we are dealing with a faulty chip right here. That would be a worst case scenario since I cannot really replace that. If I look at these solder joints, they do not really look factory to me, and we can see on the other side that one of the wires has let go. I do think this side may be factory since it has the little bend in here on the cable, which is done from the factory. But here the solder joints are not as nicely, and I basically don't ever see it from the factory like that. So I think someone has been in here before and tried to fix this. I think what I might do next is to focus on the middle chip and just check the solder joints. In fact, I will take you under the microscope for that. So here we are under the microscope, and I just want to quickly check these pins to see if all of them are still soldered properly. What you see cracking around there must be the old flux, which has been left on the board. These PlayStation 2 controllers are kinda known for that, for the very fluxy motherboards they have. But that does not mean there is a loose pin right here. This side is perfectly fine. Yeah, this side is fine as well. Also fine. Now the last side. And also perfectly fine. So I think what I will do next is to mess around with the multimeter off camera. And if I find anything that's remarkable or a little bit odd, I will be back with you. So I am back with the controller right here. As you can see, it's still open. So I should be showing a piece of recording which I, just recorded. And I found something interesting. So I'm testing on Tony Hawk 2, and basically the thing is, if you go to the main menu once the game is loaded, and if you do not do anything, the game will go to a demo basically, and the only way to skip the demo is to push any of these buttons. Interestingly enough, what happens if it loads the demo, then it doesn't play it at all. Instead, it instantly goes back to the main menu again. And that kinda gives me the suggestion that something is being pressed on these buttons somehow. Not sure how that is supposed to work, but I think I'm just going to take a chance here and just replace the flex PCB and see if the controller will give a different behavior once that is replaced with a known working one. Maybe a possibility that the flex PCB is maybe giving us trouble right now without us having any idea about it. So I think it's just better to replace it first instead of trying to fault find this. I did actually go over each of the pins with the multimeter and over some capacitors here and there and over the analog sticks, and everything is actually getting voltage. There's none missing as far as I could see. So everything from the cable, all the voltages are being provided. I do not know specifically which voltages are supposed to go where, but it looks decent. There's nothing actively missing, so I don't want to go down a rabbit hole where I'm going to measure every component on here, since I think that might be a waste of time. Instead, we will be replacing the flex PCB, and this flex PCB is faulty, and how you can tell that is by these black lines. Basically, the conductive material has blackened over time, which causes a high resistance, which means that it does not conduct properly anymore. Basically, you can see it on this side as well, and of course right here. So this is definitely faulty, and I think it is worth it to replace it. If this does happen to solve the issue, then I can tell you I have never seen something like that before, especially with the fact that the analog sticks are not even responding. We can use the same replacement, of course. And of course, it's nice that we do not need to do anything with the connector. The connector is obviously also a 90 pin connector, but we can just skip the first pin right here and connect them to the rest of the pins. So here we can slide the flex PCB in like this. Should sit nicely. Then with some tweezers we can just gently close it until both sides are fully closed. Something like that. And that's it. So that should be installed right now. Then put one screw in to keep the PCB in place. And now let's give this a try again. So I am in voiceover again, and we are about to test the controller, and you can already see it on the screen. The controller actually works again, which I wish that my initial reaction would have made it in the recording, because I was very surprised actually that this controller was now fully working again. And like I said in earlier in the video, I have never seen a controller go in a state like this, where everything is non-responsive, including the analog sticks. So I kind of went into a rabbit hole just thinking there was maybe a power related issue with the controller, when in fact it was just the flex PCB causing this. There may have been some weird internal resistances which caused the buttons to be non-responsive for me, so if I push a button nothing would happen. But at the same time, as we could see with the demo stuff, something would have been pressed in, so I'm happy that actually happened, so I was put on the right track that maybe the flex PCB was causing us problems. But luckily it was in the end a simple fix, and the same issue as with the other Model H PlayStation 2 controller. But yeah, great news that we were able to fix this, and now let's go back to the original recording so we can wrap up the video. To replace the flex PCB on these controllers. I mean, especially if you have this revision with the white connector right here, it's an absolute breeze and very easy to do yourself, even if you do not have any experience with electronics. If you just have a screwdriver, you should be able to perform something like that. So yeah, that is amazing. So that means that we are 3 for 3 with these controllers. So 3 controllers saved from the landfill. I realized I did not actually mention where I got these controllers from. I got them again from the local marketplace. I think I paid like total 14 bucks for everything, including shipping. Of course, I want to keep this controller in my own collection, and these phones, once they are fully cleaned up, I will actually sell them. I try to sell them for €10 a piece, so it should make me 20 bucks, which means that we have a little bit of profit, but at least we should not lose money on this purchase, so that's always good news. So yeah, really happy with that. I want to thank you for watching. I hope this video was somewhat informative. If it was, you can leave a like on the video, you can subscribe to the channel if you are interested in more of these videos, and I hope to see you in the next video. Have a good day.